Thank you, Alex, for the introduction, and thanks for the organizers for letting us to be here for showing what Proventia is doing, who we are, what we are doing, and yeah, like we heard, we have a lot of challenges in on-road machinery when it comes to the future generations. I will list some more challenges, but hopefully after the presentation we also see some solutions fixing these challenges step by step. So after introduction of the company itself, Proventia, then we go to the general challenges on the after-treatment systems. What are the typical development drivers and what are the key challenges? Mainly, I'm bringing some lessons learned or takeaways from the stage 4 and stage 5 development for non-road machinery. These are more or less the same what people are seeing on the Euro 6 type of or China 6 type of on-road development as well. But my point of view here is focusing on the non-road cases and mainly for the SCR. Like we heard, things can be done by EGR and SCR, either combination or either or. But we see the trend, especially in Europe, that all the OEMs are more or less going without EGR. They are skipping the EGR, so SCR is mandatory there. So, yeah, we are a Finnish company. We are system integrator. We are engineering company, competence center with the testing facilities and engineering facilities and expertise. We are for helping OEMs for finding the solutions for optimized solution for lowering the emissions to meet targets. We have two business units. One for emission control, where I'm working in. That's divided in retrofit and OEM. And OEM for us mainly means engine OEMs and machine OEMs in non-road machinery. And then another business unit is test solutions. So we develop and we sell test units for engine testing, powertrain testing, electric component testing, and so on. We have a booth here, so those who have not visited us yet, please come there. You see a lot of material, and we can have a deeper discussion on both of these. Emission control as one slide could look like this. So we do engineering services, we design, we develop the complete systems. Sometimes we select the components, catalysts, dosing systems, everything can be selected either by us or by our OEM customers or in combination. We make the design, we make the design based on the space claim, of course, back pressure targets and all this stuff. Typically, a lot of simulations are needed for CFD and FEA type of simulation we do on daily basis in-house, of course. What we have developed, we designed, we test and validate by engine testing, performance testing, aging and durability testing, and of course typical mechanical challenges or mechanical issues will be verified as well on shaker units or corrosion or you name it. And as a result, we have this tailored or tailor-made system for each applications. Having said this, of course, the target is to find as universal solution as possible to be a key part of the engine itself. That's the trend today, that it's sole component of the engine. So if it's a forklift or telehandler or water pump or tractor, harvester, more and more we target or customers are targeting for having the same kind of unit or same components to all applications, if that's possible. For our test, yeah, we have engine cells, 4 dynos for testing up to 470 kilowatts. So what we do, customer sends the engine to us, we make the basic concept development, catalyst screening, dosing parameter development. We do a lot of aging studies or durability studies, and we can run unmanned with our aging, so 24 hours in 7 days with remote control in our dynos is possible, which makes us to be fast and cost efficient in developing. Yeah, for the test solutions, the picture on the right is actually from our backyard. So we invented and we realized that we need to have more capacity because more and more projects coming in, and we didn't have space indoor. So we developed C container-based test solution for our own purposes first, but then our customers or people who visiting us, they started to be so curious on these, and they were starting to ask, can you sell these? And yes, today we sell these, and it's really a business for us to develop and design test units for engines, powertrains, or electric components like batteries, for example. And it's really modular, transportable. You can use it today in China, next year in Brazil. It takes only 2 C containers to deliver, and then 3-week installation, and it works again, roughly speaking. Yeah, Proventia. Now we go for after treatments or emission control challenges and development drivers. This more, so more and more focus on the real world conditions. We heard a good examples from the PEMS challenges, for example, and telematics we have heard during the days. So what are the requirements in the future to really control that vehicles are that clean what they claim to be? Thanks to certain OEMs in a couple of years ago, emission control companies are happy to develop things further because there's a lot of more control to come. Yeah, but real world efficiency and high demand for efficiencies are there over wide temperature areas, over different type of applications in non-road machinery, especially we saw rather nice pictures by John Deere in previous speech. What kind of applications we really have? It can be harvester machine. We are from North Finland, minus 40 degrees in winter time. SCR needs to work. DPF needs to be regenerated, minus 40 degrees ambient temperature. Same engine can be used in vineyard tractor in somewhere in South Italy, for example, plus 40 degrees. Same system, same engine, same catalysts, same dosing control systems and everything. Yeah, people are focusing on NO2, especially in Europe. This is the hot potato today. And of course, we need to be OBD compliant, but at the same time it needs to be robust for those harsh conditions. Intelligent and robust at the same time. Like I started by saying that SCR is more or less the key trend, especially in Europe. So EGR seems to be, at least most of the OEMs are getting rid of the EGR for stage 5, which means higher NOx emissions, more demand for SCR system, and all these with a limited space available. So we need to have a good designs, good compact designs. Wide operation window from full load condition to the low load conditions, different mass flows, different temperatures, and different NOx emissions, different dosing parameters. So high NOx, lot of dosing there to avoid ammonia slip. And you cannot get any wall wetting, so you need to take care of the design that you are not causing any kind of issues with the low temperature conditions. High NOx reduction targets, legislation is tighter and tighter, so more wear need to be injected because engines are emitting still NOx. We heard up to 9 grams per kilowatt hour. It's quite typical without EGR. You need to meet that with emission regulation with that kind of raw emissions. And whatever we dose, of course, catalysts need to do their work, so we need to make the design that all the ammonia molecules will be utilized for the reactions. And all these under the bonnet in the tractor or very space constrained applications, which cause certain challenges on wall wetting and deposit issues. One need to have a good mixing devices, good design. As an example, 5 dosing map from one of our OEM customer. Different temperatures from 550, 560 degrees in Celsius down to 180 degrees Celsius in dosing. So we start to dose at 180, and the highest temperature we dose is 560, 570 in some cases actually. Still the same system, no wall wetting allowed, of course. Mass flow point of view, high mass flows, high dosing rates, low mass flow, low dosing rates. You need to mix, you need to have a good uniformity before the catalyst for the ammonia. That's the playground, or that's the field we are working in. Now we have some slides on our tools, how we tackle these challenges, what are our solutions, or what is our competence to solve these issues. Yeah, engine dosing calibration, typically done by OEM. So our scope mainly is on the insulation, thermal management, to make sure that there's enough temperature inside for the reactions, to make sure that there's no local hotspots, but also on the other hand, no local cold points where the reactant is concentrated. And then design and mixing is a key hard for the system, of course. And then catalysts. In DOC, DPF, SCR, all the catalysts are of course playing the key role. Insulation. We have integrated insulation in all our after treatment systems. It can be around the whole package or partially insulated on the challenging areas. Insulation can be used for exhaust ports even. So it's a multi-layer integrated insulation allowing tighter space. We don't need the jackets for insulation. This is very good from a space claim point of view. Keeping the temperature inside, helping the reactions, of course. SCR performance, we have a higher efficiency when we have a higher exhaust gas temperatures, meaning also the better fuel economy when we have enough temperature without any engine manners. And especially in non-run machinery, skin temperature challenges are there, and the tighter the space, the more sensitive components around the after treatment systems, some kind of connectors or wire harnesses or sensors. So we need to take care of the skin temperature, and also from safe point of view, you need to have areas where the people are working all the time around the engines, and we need to make the life safe also for them. As an example of the insulation, roughly speaking, 1 meter pipe, 90 millimeter in diameter, without any insulation, you lose roughly 14 degrees per meter, starting from the 320 degrees, 390 degrees in this case. With rather thin insulation already, 12 or 30 millimeter insulation, glass fiber between the foils, or corrugated foils, we easily get a 70% or 60 to 70% lower thermal loss. So we really can help catalyst functions, for example, with rather simple thin insulation. Mixing, whatever you inject there as a AdBlue, or you want to get the ammonia out from that AdBlue. So you want to have a good mixing and good evaporation rates, and for that purpose we have developed our own swirling mixer, patented of course. So it allows shorter distance from injector, I would like to say, than any other mixer type. So from injector to the catalyst, we make sure that the evaporation happens extremely fast. Mixing is happening nicely, and the uniformity before catalyst is 0.98, 0.99 level in typical applications. For example, in stage 5, let's say 7 liter engine, from injector to the SCR inlet, the distance is roughly 30 to 40 centimeters only. This is already in market in stage 4, so it's already proven to work. In development, we are making making engine guys' life easier. As an example, orange ones are normalized. So I'm not showing the customer data, but these are normalized to 1. So typical dosing amounts in different engine load points. So the orange one is the real value, but it's normalized to 1 without our mixer. When we installed our mixer, we see the safety or optimization margin that you could dose, or you could allow 1.5 times higher NOx engine outs without any droplets hitting on the surface. So the criteria was that we didn't allow any droplets hitting on any of the surfaces. Which means if you have challenges to meet engine raw emissions to a certain level, mixer or good design could help a bit. Either to be utilized for engineering gap, or engineering margin, or safety margin for lifetime warranties and so on. What happens after mixer is of course important as well. So we simulate a lot of uniformity before SCR. We make the design that catalyst which is selected can do its job, which means that all the molecules are meeting the catalyst surface equally or uniformly. So ammonia uniformity needs to be at high level to meet the high demands for the SCR efficiency. So a lot of simulation, CFD simulation with urea droplets. We never simulate with water. We always use urea because there's a key differences in the evaporation and kinetics and mixing characteristics due to chemistry. We measure all the designs experimentally. So we simulate, but we also measure. So we have developed own measurement devices for NOx outlet scanning. So we estimate that, or we have an approximation that when the ammonia goes into the catalyst, it reacts during the that channel distance and or length, and there's no NOx out then coming out. Sensoring is also very crucial when it comes to the OPD and real-world compliance and PEMS type of things. So when the design is made and when the OPD will be in place, nobody wants to get the OPD lights without any real reason. So that is why it's very important to find the right place for NOx sensor if the OPD is based on the NOx outlet sensor, for example. We do a lot of development on this part as well. It's not enough to make the flange-to-flange nice scanning, but what happens after the scanning, where to place the NOx sensor for OPD or dosing control or whatever reasons. In retrofit we use NOx outlets also for the dosing control parameters. So we do this in every single project more or less, and sometimes it's surprisingly big amount of the development is to make the final product real working with the pipe designs. Yeah, catalysts, they are in after treatment systems naturally, so substrates need to be selected correctly, right size, right type of cell density, right type of back pressure behavior, robustness, especially for the DPAs, robustness against soot loading or ash accumulation and so on, regeneration point of view, they need to be durable enough. It's always trade-off between back pressure and performance. And coding, we have heard fuel qualities and lube oil qualities a lot during these days as well. So what kind of fuel is used, what kind of lubricant consumption is there, that always affecting on the coding selection. And we as an integrator, we need to know the catalysts that what will be used. We need to make the design based on those facts as well. Ammonia absorption and so on. We need to know these. Target of course to get the fast SCR reaction, I mean to utilize the molecules in the optimized way, which means the DOC is playing a role also for the SCR reactions. So if you poison your DOC by sulfur, you destroy your SCR as well at the same time. You need certain amount of NO2 for SCR reactions. If you don't have a functions anymore on the DOC due to sulfur poisoning, then SCR cannot do their work. One example how we see now the stage 5 in fast running programs or China 4. We are hearing now the deadlines or very limited time for the development for China 4. One approach could be standardized system, part of the engine. It could be inline, one box solution. This kind of system, so everything in one package. It can be outside of the engine compartment, but quite many of the applications we are working now for stage 5 will have this kind of design on top of the engine or on side of the engine, integrated to the engine design. If your engine is going to the water pump or forklifts or crane, small crane or excavator, it's always with the same design with the aftertreatment, always with the same components inside. So clearly lower time and money for the development. You develop practically only one robust system which can be used then for many applications. This is the approach we are now proposing for quite many OEMs today, and this is something we are already in development for with quite many OEMs in Europe. More or less, this could brought from stage 5 development to China 4 development quite easily, and that's something which we are now focusing on. Roughly speaking, the size, 100 kilowatt engine, we are speaking about 1 meter long, 25-26 diameter, depending on the substrate diameters. So one package on top of the engine or side of the engine. If you find this kind of space claim near engine, that's the design what we do. Mixture is of course crucial also in this kind of design, very short distance from the injector, and that's a key element or key competence we are having on this system. It can be axial, radial, inlet, outlet, different variables. Going to the summary, which are the key factors in optimizing the systems? Yeah, you need to know how to design, how to make the development, a lot of engineering. You need to select right components, mixture, catalysts, dosing systems. When you have selected the components, make the right design, keeping all these facts in mind. At the end, it can be short track or fast track solution or simplified solution if needed, or if time flies too fast. Contact us, come to our booth. We can show how fast we can be in development. Key message: Proventia has verified solutions. We have been in the market since stage 3 on non-robot machinery OEM. We have knowledge, we have wide experience on, if not all the challenges, but quite many challenges we have seen together with OEM customers. We have long-term customer relationships. We still have all the customers we started with the stage 3A. All of them are our customers today. We are quite flexible in component selection. We play with quite many dosing companies, dosing system companies. Injectors can be selected by us or by OEM. And same valid for the catalysts and substrates and coatings. Either we select or customer selects. That depends case by case. And then universal inline system could be the approach, could be the solution for standard system for coming needs. We are not one of the biggest company, but we are one of the most flexible and agile. So we find the right partners for all the parts we are not doing by ourselves. We do manufacture, we are tier 1 supplier, but we also license our development work for the companies which OEM prefers to use. And we localize when it's time to go there. Thanks for your attention. Thanks for staying here for the whole event, more or less.
And if we have time for any questions, please raise your hand.